This podcast is supported by Siemens, your partner for industrial-grade AI.
Hello, everybody, and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber, and it's a pleasure to talk to
Peter Sieber. Good morning, Robert. Hello, dear listener. We appreciate you having tuned in to the Industrial AI podcast.
Good morning, Peter. How are you?
Oh, I'm fine. Thank you. I think I'm traveling, mobile, working on the road in a part of Europe
and
where
you were in Houston, right?
Where the sun is shining. Oh, no, that was last week, the week before.
Yeah, you visit the OPC Foundation. What did you tell them about
No, it was
industrial
not the
AI?
OPC Foundation.
Okay.
I mean, Mike, who works at the OPC Foundation, he is part of this organizing committee of the, I think it's called the Connected Plant Conference. And that's where I was invited to, yeah. So if you want, I can share, but maybe only 2-3 thoughts, or maybe just one thought about what it is that I did. I did 2 presentations. I built them around the core idea of, combining sub-symbolic with symbolic. We talked about it before. I'm sure we're going to be talking about this very basic idea for, a couple of months maybe to come. So, because it's really about grounding, large language models on world models of representations of the world.
So please share your ideas.
Yeah, right. So more specifically, we need to...
Sorry, Peter, I have to interrupt you for a moment because I have to add a news. NextAI has promise code. Now the XLSTM code is on GitHub under an AGPL license. I'm not the open source specialist, so I asked our open source guru, Dr. Julian Feinauer, and his answer is very interesting. It's a quote: "If you use it as a service commercially, your service becomes open source." Okay. And then there was a comment from Zeb and Maximilian Beck. And once again, a quote: "We have already experimented with it in other domains and the results are looking great so far. Stay tuned for more news." In Germany, we have a saying, Timeseries, ich hör dir trapsen. That means something like, Timeseries, I can see you coming. So Timeseries maybe is also a big topic for XLSTM. That's it. Back to our topic. So please share your ideas.
We need to combine, I believe, large language models with knowledge graphs, right? So, and in the case of our industrial world, I mean, OPC way, that's the way that the people who really know about the information models, they consider OPC way information models to be the knowledge graph, right? And then I moved on, including Jakub Tomczak's genAI systems. We both referred to it, I believe, on LinkedIn. He did an article 2-3 weeks ago. And then I moved forward towards autonomous genAI based agents. The second title was actually moving towards autonomous plants, right? I mean, it's about... We've said it a couple of times before. Until a year or 2-3 back, when we did automation, it was always, now 10, 50, 100, 1,000 people are going to lose their job. But in the Western world, and I was in the United States, it's exactly the same as it is in Europe, right? We can't find people. So if we, in what I call the Western world, not sure that that's still the right terminology these days, but there you go. If we want to continue to produce, to build things and manufacture and produce things, I think there's no other way than, going into a deeper level of automation / artificial intelligence, large language models. And that's what we're here. And so I already set up a call with Jakub. So we're going to be hearing more about his specific ideas about GenAI systems in the next 2-3 weeks.
How was the feedback?
Oh yeah, well, I'm a modest guy.
Autonomous plants. Oh, wow.
There were people coming to me said it's the best presentation I've
Oh,
heard at the
no, for
conference.
sure, Peter.
You know,
Yes,
I'm
for
on,
sure.
and there was only one person saying that, right? So now there were other important people being very happy with what they heard. So
Okay. So we have a whole episode today about the holy grail of industrial AI time series. We have a new Fraunhofer approach in the main section, but you also have something in the news part, right?
right. It's the combination of both here. I wrote down exactly the same as what you mentioned.
Holy grail.
The Holy Grail, yeah, the Holy Grail. And later on, you will hear about it, dear listener, when Robert talks to Marco and to Marc Zöller, because you want to know, how can this be in the industrial world? I mean, time series is the A and O, we say. It's from the beginning to the end. I mean, our factories don't run without time series data, and that's got nothing to do with the fact that we've been doing data science, artificial intelligence for, let's say, 10 years, right? I mean, that's been happening now as long as we have PLCs, so to say, right? As long as we have, doesn't matter if they were the separate gray boxes introduced in, I think, 1950, 60, or then 20 years later, the PC-based boxes. It's whatever it is that we measure, whatever it is that we automate in the plant, it has always been, you try to, or you set up a clock, and the clock is typically a millisecond clock, and sometimes moves even further into the nanoseconds, right, with specific communication protocols. But it doesn't matter. And whatever we're measuring, whatever temperature, pressure, whatever sensors, values we have, they're all on the same, typically millisecond spot. And because we've been doing that, it's a wonderful world actually in which we've moved into with data science and artificial intelligence, because we have those data. If we then have, and that's what we will talk about a little bit more. You did also with Marco and Marc, then we can, have these wonderful algorithms, look at what the different variables of the different sensors at a specific time, 23.123 milliseconds was. And that's amazing. So, and having said that, you were also wondering how is it then that we don't have, solutions, or that we have a number of, but why has the market not been concentrating?
Yeah, that everybody is concentrated on different approaches and not about time series, and in special case with Marco about AutoML, right?
Right, and that is what your podcast with both of them is about. So we're talking maybe 3 different solutions today, and 2 of them I just want to mention shortly, and they have a structurally different approach
exactly
to the one that Marco and Marc have been working on. So maybe starting as a very quick introduction into the one that they have done. They call it Auto-Sktime, right?
Yes.
They use AutoML. We've talked about AutoML. We had the originator of AutoML, Frank Hutter, with us.
Frank,
when was that? Last year at our conference?
Last year in AI at the Forest?
Yes, exactly.
In the Black Forest at Aachen, yeah.
Right.
Yep.
So AutoML, automating the complete process, right? Creating, evaluating, deploying models. Yes. And that's what already at that time, I believe Marco suggested he was looking into. So he's gotten together. Now, we have seen AutoML tools. So if we look at an overview, maybe going back, and I can confirm going back as far as at the very beginning. And as I just mentioned, we've been doing this kind of time series forecasting before. And at the beginning, they were statistical models. And the one that people may have heard about, and those of you data scientists, listeners, that have been doing this themselves, the number one is called ARIMA. It stands for Autoregressive Integrated Moving Average, a statistical approach.
Yes.
Could do specific things and could not do other things. And that's the time where I recall I was working with Softing, Industrial Data Intelligence, startup. Weidmuller was there even before us. We've had Weidmuller.
Carlos, yes.
And they were the kind of solutions that we, and I assume also Weidmuller at that time, were using, number one, but not only, because we started at the time that actually machine learning models, that's the second group, right, that they came in. So you have terminologies like random forest, gradient boosting, whatever. I mean, there's like whatever, 5, 10, there's 100, but there's like 5 or 10 that most of the people use and are most successful. And then you have probably, I would say, maybe the third category, or actually combining with machine learning, is the neural networks, including like LSTM, right? That famous LSTM. I recall that when I was at our industrial data intelligence, I had a student at that time in my office, and he was trying out neural networks at that time with no success, but there you go. And then two more categories, and actually in their work, you didn't talk about it specifically, I believe, but in their paper, which I'm sure we're making a reference to,
yes,
they talk about that lately we've seen transformers, and that's what I'll talk about in a moment. We'll talk about in a moment. But the one that they refer to is from 2021, and just lately, the two that I talk about, they are just from the last couple of months, so to say. And then maybe to say there is prior work on AutoML. Of course, there's a lot on AutoML, and also a couple of solutions that have been dealing with a time series. But basically, they did a benchmark. They have included a number of improvements, and we're not going to go into the details. I think it is typically maybe too detailed for the majority of our listeners. But those of you that are interested, you're going to read it in the paper. And in the end, they do benchmarking, and what they come out with is that they outperform the existing AutoML frameworks for time series forecasting.
But one more question, Peter, because you mentioned Frank Hutter, but Frank now also wants to make an LLM, right? He wrote us an email, and now is also on the LLM track.
That's a very good question. Yeah. Well, I mean, it's not a question.
It's not a question.
You're suggesting that maybe he's moving. At the very end, actually, you ask Marc. So you have two persons. You have Marco that most of you listeners know, and then Marc. And then Marc, who has maybe done most of the work, I believe, of the paper, he has also moved on into LLMs. So let's combine it with that. What can I say more?
Is it possible now to combine both worlds?
Why not? If I again go back to my first statement of the presentation I did in Houston, and of my personal thinking, which is not a structurally completely new thinking. It's you can sometimes say that certain things happen all around the world, right? And then you just deal with them. So it's also the combining, and what I see LLMs are going to be used for is as this user interface, and that's Jakob's very specific idea.
Yes,
multimodal user interface, audio, as you and I do right now. We do not use video. We could if we wanted. We could put it up on YouTube, and you could see and then wife would tell me to make sure that I would have been shaved before. And now I don't have to do that. Because you can't see me. But the LLMs are going to be the user interface. And then behind that is what we're going to be calling agents. We've referred to it a couple of times.
Exactly.
And I'm not going to talk for Frank. He will share, I'm sure, with us at some point in time. Yes, you're right. Was he trying to get funding from the European Union?
Yeah.
I believe, something like that.
Yeah.
Open source European languages. Right. So having said, very quickly, I want to refer to the two other ones. Because yes, I would agree, Holy Grail, and this was the time. This is the week, the 2 weeks. A couple of other things happened. AI Act got finally approved. We don't need to talk about that. We do need to talk about it, and we will in our next conference. Actually, nobody listening, wanting, interested in doing, in bringing AI to the European market, you have to know what it is. So, but we'll talk about that another time. But I think the last week, 2 weeks was time series was the big thing. So the other two ones, very quickly, a company I'd never heard about, Nixtla.
Nixtla, never heard.
Nixtla, no, me neither. And they brought a solution to the market. They call it TimeGPT-1. And I just do a quote unquote, Nixtla democratizes access to state-of-the-art predictive insights, eliminating the need for a dedicated team of machine learning engineers. That's a big claim. It's not a new claim, right? It's about what Gartner has called the citizen data scientist 5 years ago, but I've talked about it. We've talked about it a lot. I've always said, we need these solutions for the domain experts, and they use different verbiage here, but that's what it is they say they do, right? So they call the TimeGPT the first foundation model for time series. They evaluate it against established here statistical, number one, machine learning, number two, and deep learning. So exactly the same as what Marco and team has done along the lines of the evolution that I just shared with you and our listeners. Mm-hmm. And just to finish on this one, they say TimeGPT zero-shot inference excels in performance, efficiency, simplicity. I'm not going to go into the details. For those of you, we should share also these two papers.
Do you record an episode with them?
We can look into that. Yep. Yeah, I've been asking a couple of people.
Okay.
Maybe we're not gonna. Well, maybe we're not gonna record with each of them. We can, but what I'm most interested in, I already checked. I haven't found yet, but any of you now listening also interested, and if you are the person who has the biggest, knowledge overview on time series in the industrial environment and what's happening today with foundation models, with AutoML, and what we just quickly talk about now, let us know. My feeling would be that maybe the one person who comes maybe from one of these companies or another person that has like the meta knowledge that can tell us. And, it can, of course, we're very, very much interested in one of you guys and girls in the industrial setting that have been trying out, maybe with a team of people that is willing to share, we've tested A, B, C, and D, and for the moment we're going to go with whatever. So then the final one I do want to share with you is then TimesFM by Google. It's a time series foundation model, out of the box, zero shot. And that is important, right? So, and I will share at the very end a quote by Marco Huber, because that was, of course, my question to him yesterday. So what you're going to hear today when Robert and I finish is Robert's interview with the guys. It's about AutoML based. That's one approach, has its advantage. And these two that I'm referring to now, they are foundation models. They are language models based time series, which is, of course, the thing. You just asked me the question. Mm-hmm. The guy who's been doing AutoML, Frank Hutter, is now doing large language models as well. Yeah. So let's see what they tell of themselves. What is important is that they have a training corpus, which is both real world and also synthetic data. And they do the same thing, performs on a variety of public data sets, and they say comes close to the accuracy of state-of-the-art supervised forecasting. Mm-hmm. Right. So bringing it all together, of course, yesterday, as I was preparing, I wanted to know from Marco. I had this feeling that he may be working, and he did answer immediately. So Marco, I said, how would you guess Auto-Sktime, so that is their solution, to benchmark against the time series foundation models like the two that I just mentioned, TimeGPT by Nixtla.
And what was his answer?
No. And very important, between brackets, I said, as I'm aware, neither of them have seen any industrial data. And I thought that might be important. Now, that's maybe the same actually for Auto-Sktime. Now, so Marco says, in addition to the interview that you're going to listen to right now, he says, Peter, without having actually tested it, I would hypothesize that Auto-Sktime, so that is the AutoML-based solution, outperforms both of these foundation model solutions, especially on industrial data, as it optimizes the whole machine learning pipeline. and supports some best practice time series pre-processing methods. But he says it offers no, zero, or few shot capability, being a plus for transformer models. So very professional.
Yeah.
Marco is a very professional scientist. He says, he sees, if I put it together in my understanding, he does assume, he can only hypothesize until maybe, the next time another student of his is going to move it further and going to do exactly that, are going to benchmark also, are going to extend the benchmark of Auto-Sktime against the foundation model-based solutions. He still believes that at the moment the AutoML would be better, but he says you will still need to put time into it, although it's AutoML, because he says, if you're going to be able to use a solution that is foundation model based, that's a large language based, then, you sit down and say,
Exactly.
okay, large language model, here's the data, give me whatever, give me my problem, give me my whatever it is that you should, that I should know. Right.
And now we have talked about them so much. Let's listen in to Marco and Marc in the main part. Thank you, Peter. It was a pleasure.
Robert, thank you very much. Have a good day. And dear listener, have a good day. And looking forward to have you listen to us again soon.
Bye.
Bye-bye.
Today we talk about the holy grail of industrial AI, time series combined with an AutoML approach. My guests are Professor Dr. Marco Huber von Fraunhofer IPA. Hello, Marco. Welcome back.
Yeah, hello. Nice having me again.
And Marc Zöller, Senior Machine Learning Engineer at GFT. Hello, Marc. Welcome.
Hello, thank you for inviting me.
You're welcome. Today we are going to talk about a paper that you both wrote together with some other authors. I think Professor Marius Lindauer was also a crucial part. And the title is Auto-Sktime Automated Time Series Forecasting. Marco, is the management summary we now can do time series in AutoML?
Yes, that's a very good management summary. Actually, we're not the first one, of course, who are concerned with this topic, but I think we made a major leap forward to improve automated machine learning for time series data.
And Sktime is an acronym for sklearn, right?
Yeah, we took this famous sklearn package in Python, which is having a lot of machine learning libraries, as a motivation for the name of our approach.
Marc, why was it so complicated in the past, time series and AutoML?
I'm not even sure if I would call it complicated in the past. I would rather say it was a topic that did not have so much attention in the past time.
Why?
So historically, people just focused on supervised learning, so classification and regression tasks for tabular data. I would assume just because it's like one of the very first data types you occur.
Yeah.
So a lot of research was focused on these topics, and a lot of improvements were made in that area, in that specific learning problem. And just recently, the research community moved to considering other types of data. So one of the first other data types that was considered was like vision data, so images and stuff like that. And time series are just not like, I would say, such an important or a common data type in the research area.
But in the industrial sector, it's crucial, right?
Definitely. So there's like I would say, little gap between what's going on in research and what's going on in the industrial application of the research. And so that's also like one of the core topics of my PhD thesis. So bridging the gap between AutoML research and bringing all the research really to the application in an industrial manufacturing context. Mm-hmm. And therefore, there was this obvious gap of, okay, we need something better for time series.
So you published a paper and also a GitHub repository. So is there also a tool now? And what can your tool do?
Yeah, so there's a tool called Auto-Sktime. Mm-hmm. So I'm a huge fan of like making research public, and I try to make everything open source that I worked on. So feel free to check it out. Just search for Auto-Sktime on GitHub. You will find it. And it's very similar, I would say, to Auto-Sklearn. And it has the same approach. So there's like scikit-learn mm-hmm. with all the basic machine learning algorithms. Auto-Sklearn brings the AutoML part to it. Mm-hmm. And similarly, there's Sktime, that has all the time series forecasting algorithm basics, and Auto-Sktime adds the AutoML part to that.
Mm-hmm. You mentioned it's not so complicated with time series, but what needed to be changed in your tool compared to sklearn?
So I think the difference to the other AutoML approaches out there that tried to tackle time series is that we decided to not treat time series data as tabular data. So there's always the approach of like using a sliding window with fixed length and transforming time series to tabular data. And we deliberately decided to not follow this approach and try to look into dedicated methods for time series data. And we made like 3 proposed improvements for that. So first one is for time series, you have like, I would say 3 classes of algorithms you can use for forecasting. So you have some kind of statistical approaches like ARIMA, for example. You have machine learning approaches like gradient boosting. And you have like this huge neural networks, LSTMs, and all that stuff.
Mm-hmm.
And we spent some time thinking about, okay, how can we combine these 3 fundamentally different classes of algorithms into one framework? So that was one improvement. And the other one is that multi-fidelity approximations are one of the key drivers for AutoML performance in the last year. So it's all about how can we fit models faster, have a rough first estimation of how good like a specific setting of hyperparameters and algorithms could be, and like extrapolate that to training it, for example, on the full data instead of just a fraction of the data set.
How do you do that?
For time series?
Yeah.
So we looked at different approaches, how you can tackle the problem. For example, a very common approach for tabular data is that you just use a subset of the data. Mm-hmm. Because you have like this IID assumption about the recorded data points for tabular data, so you can just like drop some of them without distorting your distribution. But for time series, this does not hold true. If I just remove some random points in my time series is totally distorted. I lose the periodicity. It's total mess. So what we decided to do in the end is this very simple approach. We just take like the last fraction of the time series. So we look at the end, and with an increasing fidelity, we increase the length of the time series to the beginning. So we always include the most recent data and go farther back into the past with increasing fidelities. And that's like a common theme for the paper. We have very simple ideas that we apply to time series, and they work surprisingly well.
Were you surprised that it works so well?
A little bit, yes. So from a, I would say, purely research technical perspective, there isn't so much in the paper. So it's very simple ideas, very simple to follow, and with surprisingly good performance. So I would say that's also like one important point, that you don't always have to use like LSTMs or more sophisticated neural networks to do time series forecasting. You can go with you get surprising good performance with just sticking to very simple ARIMA, ETS models, stuff like that, and just fine-tuning them.
Marco, why hasn't anyone else done this before?
Very good question. So actually we took ideas that were published already elsewhere, like the multi-fidelity idea Marc just explained, or how to incorporate prior information into the learning to speed up the hyperparameter fitting. I think the novelty from our side is really to combine them all together to improve significantly the performance of the AutoML approach for time series data.
How do you measure the performance?
Well, that's typical as always. So we took a lot of publicly available data sets. I think it was more than 60 that we used. And then we compared our approach with recent state-of-the-art algorithms, so many of them. And then we took some measures like the error on the prediction performance, for instance, but also the runtime, for instance. And based on that, we calculated average performance and made a ranking. And especially when it came to the prediction error, our approach significantly outperformed the state of the art.
Okay. And is there a limit of size of the data?
Not in principle, but I think these details Marc can better explain.
Yeah. So there's no like hard upper limit the algorithm is able to handle. So for the evaluation, we focused on, I would say, rather small data sets. So either short time series or just like a few number of time series, not like this huge M3, M4 time series benchmarking data sets where you have like millions of time series that are included and all very long. So that was also like a deliberate decision to more focus on shorter time series with not so many data points. So to give you some numbers, shortest means, so the longest time series that we have evaluated was like 150,000 data points, and the shortest was like 150 data points. So still, I would say like reasonable length, but not like gigabytes of data that you have to provide.
Mm-hmm. What does it mean for industrial applications now, Marco?
I think it's a step forward. So in industry, as you mentioned, it is time series data is one of the most common one, but there's this gap Marc just mentioned between what research is actually focusing on, which is a lot of vision image data.
Why is it so popular? And why is time series are not so popular in academia?
It's difficult. Actually, the benefit of images and also text is, as a human, you easily understand. And if you provide an algorithm, you can more easily assess what is going right in the wrong direction. Time series instead is very abstract, makes it complicated to understand maybe some issues with your algorithm. I think this is one of the key reasons why the focus is not that much on time series data.
And once again, what does it mean now for industrial applications, the tool? What is possible now?
In principle, it's possible really to automate the learning. And actually, we had another paper last year where we showed a specific use case in industry, which is very common, which is called remaining useful life prediction. So the idea is to predict the lifespan of a machine component, which is a prerequisite for doing a predictive maintenance. You need to know at which point in time you might have an issue with your machine component in order to plan in some maintenance work. And therefore, we used an earlier version of Auto-Sktime, we dubbed Auto-RUL, where Timeseries theory is used to predict this time span. So there we were able to show that it significantly takes away working load from either a machine learning expert or a domain expert in order to solve this problem of remaining useful life prediction.
Mm-hmm. Marc, I want to come back to your multi-fidelity optimization. You highlighted two more points. You highlighted the pipeline templates and you call it warm start technique. Can you please explain what does this mean?
Yeah, so that's like a very common problem that you have in AutoML. So basically, a simple AutoML tool always starts from scratch when you give it a new data set. Mm-hmm. And that's just not the way humans work. So we have some stuff learned, we have some intuition how to approach a problem, and we can pour our prior knowledge into solving the problem and don't start from like random guessing what solutions could be and improving from there. And that's the whole idea of a warm starting, how to bring knowledge from prior optimizations into the current data set I'm looking at. Mm-hmm. So that's also like a very, I would say, old idea in AutoML that it's very useful to invest into warm starting because it just speeds up the optimization run because you don't have to do random trials in the beginning. And we also thought about how to improve that or how to apply that for time series. And we came up with an approach that's actually time series agnostic. So you can also apply it to other data types. Mm-hmm. And the idea is just that you take a look at prior optimization runs that you have done and at the so-called configurations that were evaluated. So configuration is just like a combination of model and hyperparameter values. So like one specific ML model that was trained. And then you can just like fit a distribution about the well-performing configuration values. So if, for example, you have like a support vector machine, you have different values for the hyperparameter C, and you just take the well-performing ones and fit a kernel density estimation to it. So you have like a probability distribution, how that looks like, the well-performing values. And then we use that as a prior and multiply it to like our belief where good values should be. So we have like two components in our optimization. So one is learned from the actual data set, and one is like a prior distribution that's multiplied to the other distribution that's learned. And this improvement is based on another work, and we just like improved how this prior distribution is learned. So in the other related work, it was like set by hand. So a user can provide his personal beliefs, where he says, I want to have like larger values of C, and therefore I put it like a prior there. And what we did is that we automatically learn this prior because it's very difficult. So for a modern AutoML system, you have like hundreds of different hyperparameters that are optimized or that can be selected from. And it's just not feasible to provide all these distributions by hand. And therefore, we implemented a method to automatically learn those.
And you also provide a pipeline templates, right?
Yeah, exactly. So we have like multiple templates. So I mentioned those 3 classes of algorithms in the beginning. And we have like one, I would say, general purpose template for each of those different classes of algorithms, and they are combined together in one search space. So the optimizer, the AutoML optimizer, can select which pipeline template to select. During the optimization, it is free to switch anytime. It's just because we like use different pre-processing methods depending on the forecasting method that is used later on.
From your point of view, Marc, how time-consuming or how difficult is it to use a tool for a machine building company to start?
I spent quite a lot of time to make it easy to use, but okay. I have to be fair. So if you're like expecting a fully fledged software tool library you can just plug in and use and everything is fine, that's probably will not be the case because it was basically developed by myself. And I mean, that's like I would say, general problem with research, that you develop code to write a paper and you spend some time to make it like a usable tool afterwards, but it's not like the primary goal to develop a very cool, sophisticated, I don't know, ML library, AutoML library, and write a paper about that. So there's like a switch in priority. Therefore, I hope it's good to use or easy to use, but probably there will be some issues in there, I would assume.
So the main focus is, Marco, that companies, for example, like Beckhoff, using this approach to build an own AutoML tool, right? Or am I wrong?
Yeah, that's right. So it would be somehow of a backend, and it would need some additional software engineering to really integrate it in, let's say, the internal infrastructure of a specific company like Beckhoff you mentioned. So it's a research tool. Everybody needs to be aware of that you cannot expect a full-fledged developed professional software tool, but it's a good backend, and there needs to be some effort spent in by a company if they want to make a product out of that, for instance.
Well, you are not building a product out of it.
We as Fraunhofer, of course, we could go a bit
with a startup.
Yeah, a startup would be an option based on that, to use as a backend and provide services on top of that. That might be some way. But as you mentioned, in Fraunhofer, we could support companies in order to make use of this tool, but really to do a software product the better way than would to form a startup out of that.
What about you, Marc?
I'm not really like...
You want to have the paycheck at the end of the month.
Yeah, I mean, payment is of course part of it, but I just have to be honest, I'm not like really the creative, innovative person. I'm more like a person building stuff. I'm very good at that, but I'm not very good at coming up with ideas and how to like make a real product out of it. That's not my strength.
What are your next steps, Marc?
So this work was basically the last paper I did for my PhD thesis. So I just submitted that last month, I think, or roughly 1 month ago. And now I just switched my employer to GFT and doing...
And AutoML is a thing of the past for you now, or?
Yeah, so right now I'm working on generative AI, like
everybody.
Many people, like everybody. So I'm working in that area, and AutoML is currently not a focus of my work anymore. But I think there are still a lot of overlap and a lot of small sub problems AutoML can still be applied to. But I'm not like staying in research. I'm more in industry right now.
Marco, how will AutoML develop further? Is it an accelerator or an enabler? What is your opinion?
It's both of it, I would say. It's an accelerator, especially, and this was always an intention behind AutoML research, an enabler for people or companies which do not have sufficient machine learning data science resources. So the idea is that a domain expert who knows a specific machinery or something like, but has not the skills of developing decent machine learning code, uses tools like Auto-Sktime in order to come up with a machine learning solution. But it also supports data scientists. This is something we also learned from prior research we did. We did a survey on that, and we learned that also data scientists, which have a lot of experience, like to use AutoML tools to come up with, let's say, a version 0 of a good machine learning pipeline, but then spend a manual effort to further improve that. So to get a head start, so to say, using AutoML. So it's an enabler. Yeah.
But I think it's not a business case, right? When we talked about Beckhoff because they published their first AutoML tool based on a vision approach. And my question is, when will the automation companies offer AutoML tools to their customers? Because I thought that's the business case for them.
Yeah, I doubt this is a bit. I think customers to Beckhoff probably do not want to build their own machine learning solution. They won't have complete services. So it would be probably supporting Beckhoff itself in order to come up with a nice machine learning solutions. But their customer at the end very likely would like to have a fully developed, complete solution without spending additional effort in running AutoML or similar tools.
Yeah. But they should integrate it in their software products, but I don't see that.
Yeah, that's probably right. Also from our side. So for instance, AutoML is also not key of our own research. So we sometimes use it, but we did not spend that additional effort to further improve AutoML. First, of course, there are others like Marius Lindauer, our co-worker, or Frank Hutter, which are really strong on that. But from a applied research perspective, it's really applying it, but not further improving that. That's fundamental research to our opinion.
But it's very interesting when you talk to Frank Hutter, for example, and he says, yeah, our industry wants to have AutoML. His industry are AWS, Microsoft, and all the big players in the AI field. And his industry is not our machine building companies. Yeah, that's interesting, I think.
Yeah. I can fully understand, because these companies you mentioned that maybe Frank Hutter is targeting on have a huge army of data science and machine learning experts. And for them, it might be really a tool for supporting. But these industry companies either would like a finalized product that might have machine learning included, but would not like to deal with it. It just needs to work at the end.
It doesn't matter if it's AutoML or something else.
Yes, that doesn't matter. It's just technology at the end, and it should work. And that's it.
Thank you, guys. It was a pleasure. Thank you, Marc. All the best with your new job and with your genAI projects at GFT. And Marco, it was a pleasure. Thank you very much talking about AutoML with Fraunhofer IPA. Thank you.
Thank you. It was a pleasure.
Thanks for inviting.